let n be the positive integer. Mario has a binary string s of length, and in one move he can choose any position I such that it's between ones, and then set si to either 1 or 0. Mario can perform this operation as many times as he wants. What is the minimum and the maximum number of ones that can be result? Okay, he can choose between ones. Okay, so okay, that's that. He can choose between ones. That's 3 and okay. So it doesn't change actually that much. Let's see this example. Okay, 1 0 1 1 1 0 1. Okay, I can choose this one. Yeah, I can choose this one and get my answer. And for the other state, it doesn't matter which I choose. I can choose this one and this stays the same. If 3 continuous, I can just do it manually actually. Max and mean. So two, 3, 4. Okay, second case it got 4, but it should be 3 actually. Second case 0 1 1 0 1 1. It should be 3. I can change this one. I can change this. No, I cannot change that one. Or I can. 3. I can make it 1. If I make it 1, then there will be 1 1 1 1 1. Okay. Then I'll select this one, it will be 0. I'll select this one, it will be 0 1 2, yeah. Okay, got it actually. So it will gonna be 1 1 1 1 1. So I'll make it 0. I'll make that 0. So 3 answers. So it should be something like that actually. So making everything 1 is a good option. If that's the case, then s I equal to 1. Okay, I don't even need the count. If si 1 count plus let's now count 1. Okay. Count equal to actually count 1, and if that happens, then si equal to 0 and count minus 0 count to space count 1. I always get wrong on easy question actually. Not always, most of the time. Okay, I'm not gonna get wow. Okay, let n ml be the positive integer. You have made the unfortunate decision to work as a night guard as a Freddy Fazz what the heck Fazbear's Pizzeria, where there are animators number from 1 to m waiting to jump scare you. The night consists of L seconds, number from 1 to L. The jet of the m animators has a damage level of dj, and initially dj equal to dm equal everything is 0. Every second the damage level of exactly one animator will increase by 1, and throughout the night you are able to observe all values of dj at the current time. For example, if m equal to 2, one possible list of the danger level after 5 seconds, d1 d2 equal to something. You are not defenseless. However, at each of the nth fixed time ai, you can shine your flashlight on exactly one animator's j of your choice. This occurs immediately after 8 seconds and sets its damage level to 0. Okay, note that this choice is made independently for each flashlight use of AI. Current counting the example from before, a equal to 5 and and you choose to flash the second animator at that time, the damage will 0. Okay, let the overall damage be the maximum damage across all animator. DJ, you will lose if overall damage at the end of the night is greater than X. Find the maximum value of X such that regardless of the action of the animators, you can guarantee that overall damage will be at least there or equal to X. Net, what is this stuff? Okay, say YouTube too. A night consists of okay, let's see example. NML, number of flashlight action animators, and the light length of the night. Okay, and next line contain the time at which you get to shine your light. Okay. In the first test case, there are 2 animators and a night length of 10, and you get a flash after 10 seconds. You will show that f x equal to 5 is always possible. X equal to 5 values after 10 seconds. Notice that that one animals must have at least 5 damage and the other must have at most 5 damage. So we can flash the highest one and get a final danger level of at most 5. It can be shown that. Okay, got the point. For the next test case, the answer is 7. Okay, I can flash 1 from 9, 16, 5. In the second test case, there is only one anime and okay, only one. So let's read the question again. Actually, the night consists of L seconds, 1 to L. The jet of the animators have animatoronus has a dangerous levels of DJ, and initially danger is 0. Every second a danger level of exactly 1 increase 1, and through the night you are able to observe all values of DJ at the current time. For example, if m equal to 2, one possible list of the danger level after 5 seconds is D1 something something. You are not defenseless. However, at each of n fixed time AI, you can shine your flashlight on exactly one animators JI of your choice. This occurs immediately after AI second and set 0. Note that this choice made independently for each flashes. Counting the examples, chose something equal to 5. You chose a flash second at okay. Let the overall danger be the maximum danger across all animator. Let the overall danger be the maximum. Okay, you will lose if overall damage at the end of the night. Let overall damage be the maximum damage across all animator. Danger. It is guaranteed X. Find the maximum value of X such that regardless of the action of the animator, you can guarantee overall danger. Okay. So it said answer is 19, and I have how many animator? NML, and the number of flashlight and animator. Okay, 1 and 32. Okay, let me make sure I have understood the question. 1, 4, 9, 16, 25, at second 1 0 and second 4 it will again have 0, but difference between them is 3 2 3 4 3. Difference between them is 4 5. Difference is 7. Where is my calculator? Minus 9 7. 25 minus 16 is 9, but answer is 19 somehow. Sorry, answer is 7 actually. Yeah, but 16 minus 20, 16 minus 26, that's 9 actually. So why that's not the answer? Then 32, there is no flash, so 32 minus 25, that's 7 again. In the second test case, there is only one animator and the night through 32. Notice that this case the animator just increments its danger by 1 each second. So after 25 second we reset zeros, 7 more second pass before the night end, so the final danger will be 7. Okay, did it ask for the final danger? Loss, you will lose if the overall danger at the end of the night is greater than x. Find the maximum value x such that regardless. Okay, I think I got the question. Yeah, I think I did understood the question pretty well. So 2 3 40 is too much for now. I can flash at what? At 13 and at 37. Okay, so at 13 I have three options. I have three options, so let's distribute them properly. For 13, if I distribute them, 13 divided by 3, that's 4. Then 4 4 5. Then I'll delete this one and I'll have them and 0. For 37, obviously I'll next 37 minus 13, 24 moves, 24 moves plus 4 4 8 plus 8, so divided by 3, that's 10. So 10 10, 1 is 11, so I remove that. So 10 is my current max. So the night is 40, so 40 minus 37 3, so answer is 19 actually, not. Answer is 19. In the third test, it can be proved the minimum possible value of x is 19. It asks for maximum, then it said minimum. 19. Somehow it's 19. Okay, let's do it manually actually. So it's at 5, so I'm resetting into 0. So I'm at second 30, so at 14 15 16 17 18 all up to 30 36, I guess. all up to 5, 3, 4, 5, yeah, all up to 37. So there is total 37 minus 13, say 5 minus 3, that's 2 moves, 1, yeah, 37 minus 30, that's 24 moves. 24 moves. I'm gonna put 6 moves here, 6, 6, and 11 move here. So total will be 6 plus 6 plus 11, 23, 23, 23 plus 30, 36. It gets 36. It gets 36. Okay. Oh, 11. Sorry, I'll put 7 here. So 11, 11, 10, 11, 11. So I got 11 plus 10, 32. Oh, sorry, 6 plus 7 plus 11, 24 plus 13, 37. Yeah, that's correct. So I'll reset 1, 0. Then I have 3 moves. So plus 3. So it should be 14 actually. I don't see how it's getting confused. 14. Yeah, max can be 14, but it said it's 19 somehow. Note that let the overall danger be the maximum danger across all animators. DJ, you will lose if the overall danger at the end of the night is greater than x. Find the maximum value of x such that regardless of the action of the animators, you can guarantee that overall danger will be less than or equal. It makes let the overall danger be the maximum danger across all animators. Okay, DJ, you will lose if the overall danger at the end of the night is greater than x. Find the maximum value of x such that regardless of the action of the animator, you can guarantee all overall danger will be less than or equal to x. At the end of the night is greater than x. Find the maximum value f such that minimum value f such that the action of the animators, you can guarantee that the overall danger will be less than x. Minimum value of something. So I have 13. 4, 4, 4, 4, 5. 4 plus 4 plus 5, that's 13. 4, 4, 5. I'll flash to any of them. So let's say I got flash to this one. So I have 4 plus 5 plus 37 minus 13. 33 divided by 3. 11. So 11, 11, 11. That's weird. Oh, okay, there is a catch. If I have 3 values, no matter what, A, B, C, I have 3 values, so I'm gonna increase 2. Actually, 2 of them, not all 3 of them. So I have 13, so I'll split them. 6, 7. Okay, it will remove 7. Then I have 37 minus 13, 24. 24 by 2, that's 12. Sorry, 37 minus 13 plus 6 divided by 2, so 15, 15. Okay, I can remove one of them. Then 15 plus 3, that's 18 actually. 15 plus 3, 18, not 19. 37. Thirty-seven, 38, 39, 40. Yeah. Okay, 0, 0. I have 13, so 6 plus 7, that's 13. 6 and 7, I remove that one, so I have 6, 0. Then I have 37 minus 13, 24, 24, 24, 24. I have 24 minus 6, 18, so 6, 6. Then 18 by 2, that's 9 plus 9 plus 9 plus 9, so 6 plus 9 plus 9 plus 13, 37. So I got 15, 15. I'll remove one of them, so 15, 16, 17, 18. I got 18 but not 19, so that's a problem. It asks for find the minimum value x such that regardless of the action of the animator, you can guarantee that overall danger will be less than or equal to x. Less than or equal to, so 18 is valid. (25 minus 32). 32 minus 25, that's 7. It matches. Just why it doesn't match us, I'm really confused. 13 and 37. I have two values, A and B. Third value doesn't matter. Okay, so 13 at time 1, 6 and 7. You are different, however, each and fixed time. You can shine your flash. Is there an update? No. Exactly one animator, any animatronics of your choice. This occurs immediately after AI second and sets its danger level to 0. Note that this choice is made independent for each flashes. Use AI counting the next example of 5 and equal to 5, and you chose a flash the second animators at this time. The danger level after 5 seconds will be this, so after 5 seconds, so that's valid actually. So it will gonna be 0 and 6. Okay, then after 13, 37 minus 13, that's 24. I have 24 moves. So I'll take 6 move where, so it will gonna be -6. I have 18 moves left, so 9 plus 9 plus 9, so 15 15. Okay, 15 15. So he will eliminate any of them. 37, 38, 39, 40 plus 3, so it should be 18. Is there any better option to do? What if no, no, there's no better. I cannot see any better option actually. Six, A, B, C. I have 3 options. If I put, let's say, split them equally, so I have 13 by 3, that's 4 4 5 gets eliminated, 4 4 0. Then I have 24 moves. Now I'll do something. So 24, both are 4 4 by 2, 12 plus 4, that's 16, 16, yeah, nice. So it depends on number of moves or what. 16 plus 3, that's 19. So M can be really high. So that's a problem. Number of flashes. I need the number of flashes. Let's take this one. That is total 8 flashes and 5 people. So it's a really large example. That's also really large. So 3 7 3. So I have 5 1 2 3 4 5 values. So I'll split them equal to 1 1 1 0 0. Then after 3 seconds, one gets reset. Then 17, then I have 17 and 20. So 20 minus 17, that's 3. Again 1 1 1 1 1, 3 values gets, then 8 by 5, so 2 2 1 1 1. Oh no, 2 2 3 3 2 2, then 36 1 2 3 4. Actually I think logic should be, I have 5 values. Okay, at the here was, I have 3 values and number of flashing is 2. Number of flashing is 2. So I'll have all values. So I'll have flash plus one number of option. Actually, flash plus one number of option. Let's see does it works or not. I wasted a lot of time here. Okay, it does a little bit different. M is the number of those stuff, and L. Okay, so go to 0 and just count 1, count 2. Yeah. Two E5. I'll have 2 E5 values. Two E5. It will gonna get N square. Number of 2, number of 3. I have to find those values. How many values have number of 1, number of 2, number of 3. I'll reset one value and try to make it closer. So I think vector will vector pair long. Actually it can store at max 3 values at a time, or 4 3 actually. Yeah. Long max equal to is number of n minus I plus 1 minimum of comma m. Okay, that's the max number of I should use. A equal to equal to 0, AR of I minus P divided by mx long B equal to reminder. I need the reminder. Modem. Let's say I have some values. These are equal to A, these are equal to B. Okay. I'll reset 1 to 0. So current value is 0 and some value. Okay, some 1. Okay. Current value 0 and 1. Average case. Average case. 0 and 1, so it will gonna get reset. Okay. So let's have 3 values. It got reset to 1, 0. So it will gonna be 0. So 0, 1 and 2. Let's say I wanna add some other value. Let's say 4, and it has some reminder, unknown reminder. So actually I want to make all the values close to the average, close to average actually, close to average. So 4 plus 3 by 3, 7 by 3 is something close to 2. So I'll add 2 here, then add 1 here, add 0 here. If something is reminder, I'll go again. Total equal to 0. Look at it later. MX those many values, those many values. Okay. Okay, it's getting a little bit complicated to implement actually. I know how to do it, but it's getting a little bit complicated because I have 3 states. So vector shouldn't, let's see, there's the number of values. I want the value to as close as possible to the average. As close as average. Total. So long current equal to total plus current value. Current value is here of I minus previous. Previous divided by mx. Those are the number of values. Okay. Those are the number of values. I'm removing the previous. number of values. A can be max. Okay, I'm getting really confused for this question. How can I implement that? M can be 2 if that's the main problem. Counter. Let's say all 5 values 0 now. All 5 values are 0. 0 is all 5 values. And make everything as close as some value. So I want to make every value as close as current. So 5 values close to something. So let's say I have 3. Missing is I want to make all of them 6. Okay, so I need 5 minus 6 minus 5 plus something. Okay, so need equal to is CRN current minus A dot second into A dot first. Okay, if need greater than 0, then I'm gonna do something. I'll add some value to A. If net greater than 0, if need less than equal to new value, then just update any minus equal to need and A dot second equal to current. Okay, else if v less than equal to if v less than equal to current next how many value I can change, that's my next goal. How many item I can change, so any so let's say current is 5 and I have 6 values. Let's say current is 3 and I have 6 values. I'm gonna make them to 5. I have sum of 3. Okay, and a sum of 3 and I'm gonna make them 5. So 6 values need 6 into 2 equal to 12. So I cannot update every single one, so I'm gonna update some of them. Need equal to v minus not v minus current minus v into number of values mpv if need less than equal to ni then ni minus equal to need and mp dot erase v. Before that I'm gonna do mp. I think I should hold it actually because factor long factor long vector there vp dot insert number of current and mpv. I'll erase it later actually, not insert, it should be pushed back. See current if that is that, else it has to be divided into two sections. Two sections are I need 12 but I have only 5. Okay, so what's the minimum I can update? Minimum I can update is let's say 3. So I need 2 for every value, so 2 by 5 by 2, 5 by 2, 5 by 2, that's 2. Okay, so long a equal to is need. Nice, electricity is gone. So need actually. Okay, how much time I have? I have a lot of time. Okay, let's rethink everything. My main logic was I'll use max minus some value, so it's getting hard for me to simulate it actually. Okay, so that's that. So do I only focus on the zeroth set? I'll have two values, a and b, two different kind of values actually, a and b. Okay, a and b. A and b, total m elements. I always see the minimum one. All are minimum, so obviously everything is minimum. So at the beginning I'll have 0, all m element are 0. Okay, all m element are 0. mp, all m element are 0. I'll get the value average. I'll try to make all the values as close as, let's say, x current. Yeah, let's name it average, avg. Okay, and add. Okay, I want to make all value as close as average. So vector pair long. Let's plan before I write code. So let's say I got m values all are 0. Okay, m values all are 0, and I want to make them 2. How many are allowed actually? That's another important stuff. How many are allowed? So I should count first for auto v comma c mp long c max equal to 0, c max plus equal to count if c max greater than mx. If that happens, I have to remove some values for sure. So that's that. So I got my valid limit. Okay, valid limit, I got it. That's no problem. So next concern is, let's have c values. I want to make them as close as current, as close as to current. Okay, I want to make them as close as to current. So if cmx greater than mx. C minus equal to mx minus equal to minimum c comma cmx minus mx. Okay. Current equal to C minus current minus equal to current equal to C minus current. Current equal to C minus current. So I got my valid C. I got my valid C. Let's put that outside actually. Current equal to C. Okay, if that happens, I'm gonna do that stuff. Okay, so I got my valid value. If need equal to if V less than current, not current, AVG average less than average, I'll try to add the values. Vector dot pushback. It does the count is just the V comma CM current. Vector to push back this stuff. So I got exactly m elements, max element inside. So I'm not using add, I'm not using average, I'm not using anything. I'm just resetting every single time. Also not using this stuff. Cout CMX space mx. Let's run this one. Almost 55432. Yeah, everything is correct. Okay, I got the reset. Nicely got the reset. Now I want okay, I got my reset. That was the reset. Now how much I want to add and what's the average I want to make. Okay, that's the average I want to make. So let's say I have 5 values and I make it 6 and current value is 3. So need equal to is current value average AVG minus average V into C. If need greater than 0, then I'm gonna do something that's that is VP no A equal to is at divided by AVG that's the max value. Add divided by no, not add, yeah, add divided by AVG minus V. If A greater than equal to greater than equal to V greater than equal to C, then VP dot pushback average comma C, else it will split into two parts. If A if A, then average A, else average A, then let's say all the values are 3. Okay, I'm getting really confused. Well, let's skip this problem. Problem D, I don't know. 15,000, 1,000. That's low. Okay, let n age be the positive integer. Swappy. Let's try B again. Okay, it has really low number of summation, so let's try again. It's not trying, it's actually implementing. It's more about implementing. Let's see, is there any better implementation way, because I don't think anyone will do this kind of weird stuff. So I'll have m groups. Okay, at the beginning all can be 2e5. That's really high. That's really high. Or 2e5. 2e5 values. 2e5 values. All are x, x, y, 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 y. Okay. It will reset any x. Any x. It will reset any x to 0. In next step. First step, everything is 0. So that's no, I'm gonna do that. I'm gonna x and reset anyone to 0. So I have some x, some y. Okay. In next step, I'm gonna try to add value to 0 to make it as close as x if I can. So it will gonna be, let's say it becomes x, it becomes x, it becomes x. So I'm gonna add it to here. So I'm gonna add it here. So x and y. If it doesn't, it stays here as some value, some random value. Okay, some random value. It has, let's say 3. Okay, then I have some x. I'll remove 1x from here. It becomes complicated when I add something to x actually. Let's think in a different way. Let's do it offline. At first I have, let's take this example, this one. At first I have 13, then I have 13 minus 13 7, 24, then I have 3. That's the end product. Okay, and let's ignore that for now. So I have these two states, and I have value 3, value 2. It goes something like that. Okay, So in here I have two values, I have three values. Three value, one is gonna be 0, so I'll have two values, something like 0, 6, 6, 4, 4, 0, 4, 4. The next step, I can ignore one value, so let's ignore the minimum one. Two, 4, 1, 5. I'll remove one max, so it is gonna be removed. So 2, 4. So I'll get 0, 0, 1, 1, 0, and 2, 4. In the next step, I have to remove. I can remove 1. So I'll do that by removing that. And 24. In the current state, let's have three values. Three values in two group. Let's say X, V, Y, V. First step. In the second step, I don't remove values, so these steps makes it really confusing actually. So one will gonna become 0, and X, V1, Y, V stays same. E5, 2E5. What if I have all 2E5 values? If I values, and add something. Okay, let's skip B. I don't wanna solve it anymore. Level 3. Let n h be the positive integer. Swampy the alligator needs water for his bathtub, and you are tasked with getting it to him. Above his house, there is an h into n grid of dirt and water tail with n columns number from 1 to n. In column I, the bottom AI tiles are dirt and the rest on the top are water trail. Okay, To get water to swampy, you can place a drain on any tile that isn't dirt trail. uh, Placing a dirt trail away all water trails that can across the drain by moving only down left to right on the grid without crossing the dirt trail. For example, to get water to somebody, you can place a drain on any tile that isn't dirt trail. uh, planning planning a drain trail away all water trail that can access the drain by moving only down left or right on the grid without across the dirt. For example, placing the drain on the X in the grid below will draw both the top left and top right water tail and resulting tail 10 being drained. Yeah. What is the maximum amount of water you can get swamp after placing at most 2 drain? Note that water trails that could be taken by either drain are only counted once. Okay, it looks like a okay problem. 7 4 1 2 3 4 1 2 3 4 5 6 7. Yeah, that's the example. So if I have this kind of structure, answer is 14 because it takes 10 then this 4. Yeah, makes sense. 1 3 1 2 3 1 1. The values are h is huge, height is huge, but n is low. Okay, so it has 1, so it is connected to h, means 4 to 2, then 3, it has 3, so next value is 4 to 4 to 4, so it will gonna see that. So 4 to 4, 4 to 2, 4 to 4, next value is 4 to 2, next value is 4 to 3, next value again 4 to 4, next value is 4 to 1, 4 to 2, next value again 4 to 2. Okay, so if I connect them up, (2000) n is only 2000, so I can do n square actually. If I do n square for this value, it has 4 to 2, for this value 4 to 2, that's that. So 4 to 2 is 4 to 2 plus 1, that's 3 values, and it can access what? It can access 4 to 8 was 3 actually. 4 to 4 is not 3. 4 to 4 it can access 1, so plus 1. Then actually I don't need that much. If I prefix some from there, if I start from here, it has, if it looks there, 4 to yeah, I need n square. What is the limit of this value? they'll fall. The upper limit, yeah, upper limit is 4 now. Yeah, so +1 +1 +1 +1 +1 +1 1 2 3 4 5 6, so +6. okay, from this value upper limit still same, so 1 2 3 4 5, so I'll get the upper limits for every single value. For this one 42, upper limit is low, so upper limit is 3 now. 3 upper limit is 3 4 4 4, so it will gonna get +2 +1 +1 +1, okay, +1 +1 +1, and it will gonna get upper limit 3 4 4, so upper limit 3 means 3 4 2 2 1 1, total is 4 5 6 7 4 5 6 7 8 9, but it says it's 10 because I did a wrong calculation. It should be 3 1 2, okay, I did the wrong one. For this one 3, this one, so 2 3 4 4 4, and here is 4 4, so answer is 1 1 3 2 1 1 1, so that's that. I'll get them, I'll select one, then I'll put the upper limit to that value for there. After I get that, I'll get the maximum one. After getting the maximum one, one 3 1 2 3 1 1, I'll get from here, I'll get something like upper limit 2 3 1 2 3 3 3, then 3 3, okay, so I get that, so that's that. So new value are those are my new values. So if I see now from this part, 1 what's the limit? 3 to 3 is gone, nothing is left, so they cannot be connected. So 1 3, I have value up to 1 3, 1 and 3, so 2 3, I have 2 3, okay, 2 and 3, I have value at 2 and 3. The bottom 2 and 3, can it connect to next one? Yes, but the value is 0. When the value is 0, it's disconnected. Okay, 3 looks far simpler because I can do n square. val equal to h minus phi. If greater than equal to max equal to val and flag equal to I. Max equal to max. Putting our limitation actually. Okay, I got the limit. I'll do the same stuff again, just with this limit. Yeah, it doesn't change. H will be flag I, flag J, or flag limit J, limit J. Okay. Actually that's 3 so 3 minus 3 adds 0. Count answer plus it gave me 11. Count fell and let's take the first example. Minus is giving minus actually. Let's print for limit. Three, 1. What? 3, something is wrong, something is really wrong. So there's the limit from J equal to flag, max of limit, max of limit. Let's put the limit 0 for now. Same. That was 1. That was 1, yeah. So from 1 get up then equal to J. That goes like that. Use takes a max. J equal to Li. Max of J is of course flag. J equal to I plus 1. J less than. Yeah, everything looks good. See out. Li space. One, 3. Why that much? Why is printing that much? Wow, what? J, flag J. Okay. It might be getting okay. Flag equal to 6 means the last value. Okay, good for it. 111 something, then out allies space random. It cares nothing. Yeah, 3-1. Yeah, makes sense. So flag and everything goes out. Okay, I got this value. Then again flag. I start from every single value, and that's the limitation. Limit minus I got 3. If I start from here, I'll take everything. 1 2 3 1 2 3 4 5 6 1 2 3 4 5 6 7 8 9 10 11. It should be 11. Yeah, see out mx. Yeah, max is 11. Yeah, that's correct. Past. Nice. So D. B was just a nightmare, at least for me. Okay, let n and k be the positive integer. You are given a tree. Let n and k be the positive integer. You are given a tree with n vertices number 1 to n. Sine duck is traveling this tree and is trying to reach one of its leaves. Okay, initially he start at non-leaf vertex v, and in one turn he may either choose to stay still or move from vertex v along with an edge to any of its neighboring u. However, Snorlax is trying to sleep. Psyduck from doing this, stop Psyduck from doing this by sleeping on an edge. When he picks an edge, is blocked from traveling it until Snorlax move again. Furthermore, only one edge may be disabled at a time, so that only the most recently chosen edge is blocked. Of course, Snorlax is slow and needs some time before he can pick a new edge. He has cooldown time initially at 0. he may only choose a new edge when the cooldown is at 0 or lower, uh, but he don't have to do it immediately. When he moves to a new edge, the time is reset to k. After each of the turn, even if he steals, the countdown time will decrease by 1. Okay, they take turns acting as previously described, with Snorlax starting first, and initially he is not sleeping on any edge. Assume both of them play optimally. Can always reach a leaf after a finite number of turn. Okay. NKV, the number of vertex in the tree. KS knowledge time, starting point. Okay, I got the point. Okay, the question wasn't that confusing actually, and I've read it Snorlax as Psyduck, but it wasn't written Psyduck. I just randomly read it. Okay. Bro. One, 5, 2, 4, 3, 6. Okay, my bro is on position 1 now, and every tooth time it resets. Yes, no question. Okay, so it will gonna go here at first, at second 2. I'll block this path. Vertex blocks edge from 1 to 2. Then Snorlax can reach vertices after 2 moves. 1, 2. Okay, and it can show that. Okay, next question is test case. Does it just teleports to any position? Okay, I think he teleports immediately or something. Yeah. Bro at position 4. And its answer is 0. Yeah, makes sense. So yeah, got the question. So let's have a graph. I have a tree, not graph. Graph, same, that's same. Now let's say case something 3. Bro is let's say 1, 2, 3. You can always reach 3, 2, 2, what if let's say he comes to here, Snowflake sleeps here. Boom, he is done for it. Snowflake is living here forever. Then he comes to this position, 1 2, Snowflake sleeps here, Snowflake sleeps here. So that's the problem. From this starting position, Snowflake can block both paths. Yeah, Snowflake can stop both paths. 1. Okay, my pen doesn't have any charge. That's bad. 1 2. 1 2 3 4. From here 1 2, it has no path. From here 1 2, that's a valid distance. What's the side quick weird name. What is this? Get started. I cannot find that. Okay, let's stop it. So I'm thinking it comes here, 1 2, blocks it, 1 blocks it. From here next zero is if anything has more than one path. If anything has more than one path, from 1 okay, let's say I have a well point here in case 3, 1 2 3, it got 1 2, he goes here and blocks it. So 1 2 3 blocks it. He goes here, 1 blocks it, 1 2 3, nice. From this position I'll go to every single node because let's say I'm here and go here, box it. So 1 2 3 box it. So from this starting position, actually I can go to every single, yeah, I can go to every single one. What if difference 1 2 3 4, 1 2 3, actually no, these two are ignored. I see. Okay, these two are ignored. So less than k plus 2, difference is less than k plus 2. I think that should be the answer. Let's see another one. It has no test case 4. K is only 1, so that's obviously not possible. Difference is 1. What I claimed difference less than k plus 2. That's giving me 1, but that's giving me answer. I'm here, 1 block. Actually it's already blocked. 1, if it's already blocked, why I'll go there? I'll go to the next minimum part. This part is blocked. 1 2, at the second move, at the third move I'll reach here. He cannot do anything. 1 block. Then 1 2 3. Total distance is 1 2 3 4. So k plus 1 can be at max k plus 1, but this example destroys everything. Block. Why it's 0? It's yes, actually, my bad. Okay, he's on position 4. It doesn't matter actually in which position he's on. The cooldown is 1. The distance is 1 2 3. The distance is 3. So obviously cannot. Another no. What's the minimum distance? 1 2 3 4 5 6, but the value is 3. Yeah, I think that's the correct solution. 50 minutes. Well, let's see how I'm gonna calculate it. Calculate the minimum distance from this position, from this leaf. What's the minimum? Actually, I should start from the root. Root is the starting position. What's the distance? What's the distance? What's the distance? So there is some value. There is some value. Okay. The distance Okay, it's getting confusing. Let's see the standing. 2000, not bad actually. That's okay. Standing. Wow, 63 plus. That's a huge actually, not bad. That's too much. Okay, let's try it. For should I type B again? Because D looks, no, D isn't that hard. Let's think other stuff. Let's say the value is 2. Goes there, blocks it. Goes there, blocks it. Comes here, blocks it. Goes there, 1, 2, blocks it. So from this position, I have to see the minimum distance actually. Minimum. For minimum in all path from that position. Yeah. What am I doing even? And number of node, I think. Long ST, CNST, and long one K is the cooldown period, I think. This is K at the end. No, I did it opposite. Yeah. Is there n-1 lines? 1, 2, 3, 4, 5, yeah. And equal to is 5e5. That's huge. Why that huge vector? Push back U, okay. So I got my push back. So the minimum distance is 1, 2, 3, 4, 5, 6, and 1, 2, 3, 1, 2. Yeah, I can ignore the first value. So 1, 2, 3, 1, 2. be 118 actually. Then for equal to 0 else than I plus plus if air of dot size equal to 1, this I equal to 0. That's the 1. This v equal to minimum of this not v, this I equal to minimum of this v plus 1 comma this I. That's t comma minus 1. Let's print. Still 40 minutes left. Starting position is 1. Starting position is 1. So 1, I got 1, 2. 2 goes 2. 1 to 2. 5 goes 2. 3, 4, 5. Yeah, everything is fine. 4 auto VST. Care of ST. Pushback this V, this V. Sort L dot begin of L dot and if I'm gonna have to some value and starting value, of course not a ending value, so that's that. So always have at least 2 values. If val 0 plus val 1, this value, most of my claim 1 2 3 1 2 1 2 3 4 5. Less than k plus 1, less than equal to k plus 1. Is it right? See out. Oops. Think C, let me verify that actually. C pass. There's the key. Oh, I didn't clear. Still sequence. Why? That's the reason. Something is weird. Okay, got some output. I'm clearing that 0 to n. Vector val for auto v arrow of st. Okay, that was wrong. DSP are working. Val, I'm shorting val. That's good. A val 0 plus val 1. Dot val dot size. Two. Every single has at least 2. And that's good. So I got some outputs. So what was my claim? Let's say go here 1 2 1 it's block, 1 it's block, 1 2 block. If the value is 3 1 2 1 2 block. One block, 1 1 2 3. So yes, 1 block, 1 2 3. Let's see, it wasn't there. 1 2 block, 1 2 3, 1 2 1 block, 1 2 3. So difference should be 1 2 1 2 3 4. 4 plus 1. That's the inverter. It should give me a y actually, because the logic isn't good even if it passes. Okay, 2 2 2 2. Test just 1 1 2 1 2. Yeah, 2 2 2 2. it gets shortened to 1 actually. Okay, I cannot solve D. It is hard, little bit hard. What is this link? Now that you do it.
Ramadan is
So I think that's my limit for now. $57. I think I should try B actually, not D. Let's see what's going with my. Where is. Okay, one of my junior isn't participating in the contest. For B. BNML. I can easily do it manually. So I have some values, 2e5 values. Time is also 2e5. Let's say current max is x. I have to try to make all this value close to current max. After that, okay, so let's say I have x values, m values. I think I got a good idea how to implement it. Should I implement from the scratch? Yes, I should, I think, because I have time. Long NML. N is the number of flashes, NML. Okay, M is the total those stuff and M is the total day. Okay, so okay, got the values. I got to 0 less than and I plus plus. Okay, so my plan is, at first I say I have m values in the map. Oh, let's create the max also. Long m is equal to minimum of number of values plus 1, number of operation n minus I plus 1 minus m. Okay. So let's have a map. It has some values x, y, something. At first I'll try to make the values as close to as x. MP. At first I'll remove some values. That's my first concern. V comma count MP, also MP 0 equal to M, long CRN, C max equal to 0, C max plus equal to C. If for auto V comma C MP, if C max greater than MX, C max greater than MX, if C max greater than MX, I'll do something like C max greater than MX. If that happens, C minus equal to C max minus equal to MX, C minus equal to minimum of C max minus equal to minimum of C minus C max minus MX. Okay, new C equal to is new C equal to C minus NC, and temp dot pushback V comma NC. Okay, why it's showing error? TMP pushback V comma NC, pair temp pair, then MP dot clear for auto V comma C temp MP V equal to C. Okay, I got just cleared up needed number of value. I just have needed number of value here. Okay, so next main step, I also should do something important. If C, then push also long I equal to 0, HI equal to max of V comma HI. Okay, I'll now modify the values. I'll try to make the values as close as high. Should I okay, let's put the values in the map later actually. I'll try to make the values as close as possible. Let's have 5 3 3 2 4. Now I have some, let's say 3, value 3. Else it will divide into 2. one of the value can become max actually, not max, close to any value. Did I? Okay, I did something wrong actually. V and high. Damn. V comma NC. What is NC? Value and count. Push back. New count. Current value. Yeah. Then I'm doing again. New count, current value. Yeah. New count, current value. Count value, count. Yeah. V1 equal to value high count minus, yeah, that's correct. And is the value is gonna become high and count will stay count. No, count will let's see, there's the mistake. Value will come high and count will gonna stay count, and minus equal to, yeah, that's correct. And for here value will stay value. If that's less, it will gonna be val1, it will gonna be high and val1. High val1, yeah, it doesn't matter. So high val1 and high minus something count, it should be val1. And again I'm gonna push at plus previous val comma 1 and t2 dot push back again. Why it's showing error? At plus v, why it's showing error? Oh, I have written pop back. And t2 equal to is v comma val1 minus 1 plus 1 c minus, yeah, push back. Okay, I got every single value. Then for also add equal to 0. V comma c t2 if c greater than 0 MPV plus equal to C. Let's see, does it even runs? Yet it does runs. For this mosquito, auto v comma C MP C out V. It receives nothing. Nice implementation, Miraj. Nice, very nice implementation. 17 minutes standing. Assurance reference. Carrot. Where's my ranking? Standing. Still has 2000. 50, 40, 40 something plus. I needed 60. The candidate master couldn't solve B. Okay, little bit source account, so that's normal. C was really easy actually, but B does gives me PTSD kind of stuff. D is